Hello and welcome everyone. So I'll be explaining the problem B of the recent Codeforces round 706 div 2 problem B named max and mex. In this problem you're going to be given an array of n elements. N will be up to 10 to the power 5 and also an integer k, which is going to be up to 10 to the power 9. But remember, this n integers will all be distinct. Okay, now you will have to do some operations here. Here they have said that S is going to be a multiset, but let's forget that. I don't even need that actually. Let's assume that it's going to be an array of n integers, but n distinct integers initially here. Okay, and in this and k will be the number of times you're going to be doing a certain operations, and the final answer that you have to output is after following those k operations, what will be the total distinct values that is gonna be inside my array. Now what's gonna be the operation? The operation is that I have to add the maximum values out of the arrays and the minimum excluded value, and then I have to divide it by 2, rounded up means by ceiling. Okay, so here they have told us same operation, and after doing that operation, the values that is left for us, the resulting value is going to be inserted into our multiset, or you could call it so-called array. Okay, and finally, after allowing all the k operations, you have to answer how many distinct elements are available in my array after following all the k operation. Now if you analyze here, k is up to 10 to the power 9, which is quite a lot. I cannot do brute force. Okay, I cannot do that, but actually I do have to. If you just analyze this problem for a bit and give it a thought, you will have a certain clear observation, which actually basically what I have to do as my operation only one times. If I do only one times operation, I know what's going to be happening. So I don't have to go for multiple times of k operations. Why is that? I'll explain it. So the general approach in that problem is, first I have to check whether the array itself is sorted. Sorted meaning by distinct integers, the n distinct integers are sorted or not. If they are sorted, then the answer is going to be n plus k. If it's not sorted, then I will do only one k operations, only one operations, just like that, finding out the maximum and the finding out the minimum excluded. I hope you know how to find out minimum excluded. Minimum excluded is actually nothing but the smallest non-negative integer that is not present in the multiset. They have actually explained here, so I'm not going further to that topic. So what you basically have to do is that first try to check whether the array is increasingly, or sort the array, and then try to find out whether the array is increasing, but there won't be in between two values, consecutive two values, there won't be any other values, which means it will be increasing. It will be the array will consist of the values which, if you sort them, they will be increasing only by 1. So if that condition occurs, then the answer is going to be n plus k. If it's not, then the answer is you will do just one operation, this. Okay, try to find out the mex and then max, and then find out the value, and then insert into your set, or whatever you say, multi-set, and then try to find out what is the distinct values that left, and that's pretty much is the answer. Now the main question is, how am I saying that? What's the proof? Okay, so the proof is, now let's see, let's draw out for the what can I say, if the value is increasingly if the initial n distinct values are increasingly, and if the values increasing by only one values, okay, then how is the value n plus k all the time? It's going to be always n plus k, doesn't matter. Let me tell you how it's possible. Let's say my values are 0, 1, 2, 3, let's say 4, okay, and my k, let's suppose my k is equal to let's say 7, okay. Now n is 1, 2, 3, 4, 5. N is 5 and k is 7. Now let's do one operation here. Okay, what is the maximum value? Maximum value is 4. Okay, if the maximum value is 4, what is my MEX value? Now if you analyze it, the minimum excluded value is definitely 5. Of course it's definitely going to be 5 because I don't have any other integers here which are not filling up the gaps. Okay, all of them are filling gaps here, and not 5. If okay, now so the MEX of this array is definitely 5. Now if you do this operation, what actually happens is, if I do this 5 plus 4 is 9, 9 by 2, we know we have to do what? The upper bound, the ceiling operation. Now if you do that, 9 does not if you 9 divide by 2, what does come is a fraction number, 4.5. Now I have to take the CEIL value. What does it become? It becomes 5, which means I have to add this. Okay, I have to add this. Now one operation is gone. Now I have 6 other operations left, isn't it? Yes, I have 6 other operations. Now if I do another operation, what's it actually going to be? The maximum is 5, and the MEX is what? MEX is 6. Now if I do 5 plus 6, what's it actually going to give? It's going to give 11. 11 by 2 is what? 5.5. 5.5, if you seal it, it's going to give 6. If you add it, 6. So I hope you got that observation. It doesn't matter if the array's format is something like this, you will always add the new element will always be increasing by 1. You're going to add that. Okay, so if you see that next possible value is going to be 7, the next one is going to be 8, the next one is going to be 9. So ultimately it actually becomes n plus k. It does become n plus k. Ultimately, for each and every values, you are not getting any kind of same values. You are always getting distinct values each time if the array's format is something like this. But if this array is not like that, which means not the format that we were talking about recently, then what's going to happen? Then let's say my MEX, now only for that case that I showed you earlier, only for that case my MEX is greater than my maximum values. But for the rest of the case, okay, my MEX is greater than my maximum values, but for the rest of the case, here always be my maximum will always be greater than my MEX. I hope you get that, why it's possible, because the array is not showing the same the array's format is not the same as the previous one, because we know that MEX is what? According to the definition, according to the definition, the MEX is always what? The smallest non-negative integer that is not present in the multiset. But if the array is already something like that, where there is no smallest non-negative integers from the array, then we know what is the smallest non-negative. It's going to be the value after that, immediate value after that, after the maximum. So if the values format, the array's format is not the same as we talked earlier, then I know that always my maximum values out of the array is going to be greater than my MEX. Absolutely. And also n is distinct, so it's gonna have to be. So if for this sort of cases, and if it doesn't matter k is like super duper big or something like that, it's going to be 10 to the power 9 or something like that. It doesn't matter, because for this case, the result that it's going to give, it will always give the same result repeat by repeat, which means what actually I'm doing is, look, if MEX, what I'm actually doing, MEX plus max divided by 2, and I'm just doing it floor. Okay, now if you analyze it, you will know that, man, this is not actually giving us the, if I say that this will always give us a value which is inside MEX and max. Okay, it will always give us values which will be greater than MEX and less than or equal to max, or less than max. Okay, it will always be the result, the operation, each time that I'm gonna be doing the operation. For this case, when maximum value is greater than MEX, each operation that I'm gonna make, it's never gonna give me the real result, because the result that's gonna come out is gonna be greater than MEX and less than max. So if that happens, each time MEX and maximum value remains the same. So if they remain the same, then my new value is also, every time it's the same as the previous one. And finally, what I have to output is the distinct number of integers. I hope I made you understand that. So there are two conditions here. I'm taking you to the code part. You will understand that here. Now, here, where is the code part here? This is problem A, this is problem B. Yeah. So what we said, taking n and k, taking a set to find out how many distinct integers, and then taking the value, taking values inside my vector, and this map is actually for finding the MEX, minimum excluded, and finding the maximum values, taking inside my set. If k is equal to 0, now also one thing to notice, if k is equal to 0, I know that I don't have any other options left, so I just have to output how many distinct integers, which is actually equal to n. Okay, so I don't know why I did there. I should have output it as n. Okay, anyway, so if k is not equal to 0, I will sort the array, and I will try to check what, here I'm trying to check whether my array is increasing in terms of consecutive values difference, where that is equal to 1. If it's not equal to 1, I know that there are some values in between some two consecutive integers. If that happens, first of all, if that value satisfies the arrays, then I know that my answer is n plus k. If it does not satisfy, I know I just have to do 1 times of that operation that they just told us, and that's it. Then finally just outputting the answer of the set. How many values are inside the set. I hope I made you understand that. Till next time, goodbye.